Okay, so looking at the chapter 6 stuff, the first one you asked me about was number 1, which is y equals 5 minus x over 3 minus 4x. And it's asking me for the domain, which is really just all the possible x values. So what I'm allowed to plug in for x and the problem will still work versus what I can't plug in for x. The only thing I can't plug in for x is really going to be whatever causes this denominator to equal 0. Top doesn't matter. Plug in whatever you want. If I have 0 on the bottom, though, I get a divide by 0 error. So I just need to solve 3 minus 4x equals 0. Subtract 3 over, so I have negative 4x equals negative 3. Divide, 2 negatives make a positive, so that's where we get 3/4. So really, x can be anything other than 3/4. So we can go as far left as negative infinity all the way over to 3/4. Curves, because we can't actually be those two numbers. I can't actually reach infinity, can't actually be 3/4. Union 3/4 to positive infinity. So really this is saying that everything except for x being 3/4 will work. This is just interval notation for this type of an answer, where everything works except for 3/4. So really just look at your denominator, nothing else really matters. So just look at the bottom, figure out how to make it equal 0. So moving on, the next one you wanted was number 4, which is 25b minus 5ab divided by a squared minus 25. When it says simplify, really that's just telling us we need to factor and make sure we cancel out anything that'll cancel out. So if I look at the top of this, then looking at this, I can divide both by 5b. When I divide out or undistribute 5b, that leaves me with 5, because 5b times 5 is 25b, minus 1a. Okay, over this guy I need to factor. Anytime I have subtracting a binomial, I can just square root my factors, which leaves me a minus 5. He always needs a partner. It'll be a plus 5. That's how I ended up with just 2 terms here. So up here I have a minus 5 times a plus 5. Last thing I need to do is look and see if there's anything that might cancel or is close to. This looks like a rearranged version of one of these two guys. So I'm going to try and bring a negative out. If I bring negative 1 out, then I have negative 5b times negative 5 plus a over a minus 5 times a plus 5. Okay, well, now I can just go through and rewrite the top as negative 5b, a minus 5 instead of negative 5 plus a, over a minus 5 times a plus 5. These guys end up canceling out, so I have negative 5b over a plus 5. So really it's a matter of watching that negative to see if that negative can come out to create these two matches. Then we can cancel stuff out. What is next? 5? Okay. On 5, okay, so some exponent rules here. On 5, we have 15x squared y cubed over 3z times 6z cubed over 5xy cubed. First thing I would do, if it's multiply, divide, we do not need common denominators. Second thing I would do would be to multiply the tops and the bottoms and then simplify after that, just because it's probably going to make it easier. So if I go and I multiply straight across, 15 times 6 is 90. I have x squared, y cubed, z cubed over 5 times 3 is 15. Then I have x, y cubed, z. Now I just have to divide and simplify each one of these things. Okay. 90 divided by 15, if you don't have a calculator, go old school. So 15 can't go into 9, 15 can go into 90. Well, we already did that, so 6 times. Okay, so 90 divided by 15 is 6. X squared divided by x. When we divide exponents, we subtract them. Okay, when we divide two things with exponents, we subtract their exponents. So x squared on top, x to the first on the bottom. 2 minus 1 is just x, or x to the first. Y cubed over y cubed is y to the 0 because of 3 minus 3. So I don't really need that there. Z cubed over z to the first. Again, I'm subtracting 3 minus 1. That gives me z squared. So my final answer should be 6xz squared. For 9 is actually not bad at all. So x over 3 minus y over 4. For adding or subtracting, we do need common denominators. That says common. There we go. I don't know what's going on with that. Common denominators. So I like to go off to the side and kind of figure out what it is I need. So from my first fraction, I'm going to need a 3. From my second fraction, I'm going to need a 4. Everything I need is just getting multiplied. So taking my first fraction, I have x over 3, leave some space, minus y over 4, leave some space. Okay, this is what our goal is. So if I look at my first fraction, he needs a 4 to match that denominator. Whatever I give the bottom, I have to give the top. So times 4 on both. For the second fraction, he needs a 3 to be able to match. So again, give the 3 to the top as well. So now I have 4x over 12 minus 3y over 12. Since these finally match, I can shove everything together. 4x minus 3y over 12, and that's our final answer. Okay, now for number 10. For 10, we have a whole lot going on. So we have 2x squared plus 6x minus 20 over x squared minus 2x divided by x squared plus 7x plus 10 all over 4x squared minus 16. So first thing we're going to have to do is a whole lot of factoring, and we also need to deal with this being a division problem. So division we can't really use. So first thing I would recommend doing is making it multiplication. And then we have to flip these guys. So 4x squared minus 16, x squared plus 7x plus 10. Front group, nothing changes. Kind of like a leave change type of thing. So now I don't have to worry about the division at the very least. Looking at this, you kind of want to go piece by piece. So factor this part, factor this part, factor this part, factor this part. It's like 4 separate problems right now. So going to do this part. If I have 2x squared plus 6x minus 20, I look at this and I say, okay, 2 times negative 20 is negative 40. I need to find what multiplies to negative 40 and adds to 6. So if I start thinking negative 1, 40, that's clearly not going to work. Negative 2, 20, again, not going to work. Negative 4, positive 10. That will add to 6, so we're good. So now we have 2x squared. This minus 20 stays over here. This 6x is going to change into minus 4x plus 10x. Your professor might have had you bring a GCF out first. I'd rather do it at the end. It's easier to see. So looking at this, both of these two divide by 2x. It's the biggest thing they divide by. 2 divided by 2 is 1. X squared over x is x. Minus 4x divided by 2x is 2. Back here, they both divide by positive 10 since that's positive. That would leave me, again, with 1x minus 2. Your goal is for these to match. If they don't match, something's wrong. So now I have one factor is 1x minus 2. The other factor comes from these guys and is 2x plus 10. Okay, we always do a last glance. These do both divide by 2. So at long last, right now, this factor is 2 times x plus 5 times x minus 2. Okay, I'm going to kind of keep track of what we have going on. So right now, let's kind of keep this guy. Okay, so right now we have 2 times x plus 5 times x minus 2 over, okay, x squared minus 2x. This just has a GCF, so we can divide by x. So x times x minus 2. Okay, so we can erase this, change it to x times x minus 2. So now that left fraction is completely done. Times, okay, for 4x squared minus 16. That's the same thing as 4 times x squared minus 4. We can do that square root thing I showed you before. So 4 times x minus 2, because that's the square root of 4, times x plus 2. Meaning instead of 4x squared minus 16, now we can write 4 times x minus 2 times x plus 2. Okay, so there is that top right. And last but not least, we have x squared plus 7x plus 10. For this one, this is what I call naked factoring. If there's nothing in front of x squared, naked factoring says multiply to 10, add to 7. Okay, well 2 and 5 do that. Naked factoring means I don't have to do the whole long process that I did over here. My factors are just going to be x plus 2, x plus 5. So let's not do all that work. So once we've simplified, here's where we're at. 2 times x plus 5 times x minus 2. X times x minus 2 times 4 times x minus 2 times x plus 2. Basically, just be really patient through this. X plus 2, x plus 5. Once you've done all 4 corners, now it's just matching. You're trying to see what matches on top versus what matches on the bottom. Anything that matches can cross off with one other thing. So I see this x minus 2 and this x minus 2, so I cross them off. I can't cross off this one because there's not another x minus 2 in the bottom. I see this x plus 5 can cancel with this x plus 5. X plus 2 can go with x plus 2. And it doesn't look like anything else is gonna go. So I have 2 over x times 4 times x minus 2 over, there's nothing down there. Go 1 if you want. So finally, 2 times 4 is 8 times x minus 2 over x. And I can't simplify the x's because this is really the group x minus 2. This is a group x. Those are different. So your final answer is 8 times x minus 2 over x. Kind of a pain in the butt, but it's all good. And moving on. So 12 just looks like a hot mess. So y over x minus x over y all over x minus y over x. This situation, I avoid at all costs. So this problem is really saying y over x minus x over y, that's your top group, divided by x minus y over x. So I changed the big divide bar into a divide symbol. And now I know, okay, y over x minus x over y. Remember, we don't like dividing, so times, and we have to flip this guy when we change to multiplying. So x over x minus y. Now I need to try and get this to have common denominators. So I want the denominator to be xy. Meaning my first fraction needed a y in both places, and my second fraction needed an x. Okay? That becomes y squared minus x squared over xy. Times this guy, so x over x minus y. Now I do need to double check that I can simplify this because it is a difference of squares. So again, do that square root thing. And now we have y minus x times y plus x when we factor it over xy times x over x minus y. Okay, this group here. Well, again, this guy is really close to matching this guy. So maybe if I bring a negative 1 out of here, then I'll have negative y plus x. Oh, but isn't that the same thing if I rearrange it as x minus y? X is positive, y is negative. So I have negative 1 times x minus y times y plus x over xy times x over x minus y. This is lovely. X minus y cancels x minus y. X can cancel with x. So that means my final answer should look like negative 1 times y plus x over y. Let's check and make sure that's what your professor said. And looks like we are good to go. Okay, 13. A inverse, or sorry, negative b to the negative 1 over a to the negative second minus b to the negative second. Okay, so with this one, we need to somehow deal with these negative ones. If I square root down here, and I might be wrong. If I'm wrong, I'll rework it for you. But I'm pretty sure we can square root down there and have a to the negative first minus b to the negative first times a to the negative first plus b to the negative first. Okay, same square rooting thing we've been doing for difference of squares. Then on top, we just have a to the negative first minus b to the negative first. These two cancel. So I have 1 over a to the negative first plus b to the negative first. Okay, but a negative exponent means we really have 1 over a plus 1 over b. Okay, negative exponent changes this to 1 over a and this to 1 over b. Can't have fractions in the bottom when we're done, so right now we basically have 1 divided by 1 over a plus 1 over b. Again, remember, divide, so 1 times. We really need this to become something with common denominators, so let's do that over here. So 1 over a plus 1 over b. This guy needs a b. This guy needs an a because they have to match. So this is actually b over ab plus a over ab, which is b plus a over ab. Because we changed to times here, remember, whatever this situation was needs to flip. So we're going to flip this guy. So AB over B plus A. Well, anything times 1 is itself. So AB over B plus A. Okay. Any of these that you need me to explain further or show you more examples of, just let me know. It's not a problem. For 15x minus 21 over x equals 4. Again, I see this minus sign, so I know I need common denominators. Really, this guy and this guy need x's. So I'm going to go ahead, and to put an x down here, I need to multiply by x up top. This guy has x. The 4 needs x, so he gets x up top as well. So right now, I have x squared over x minus 21 over x equals 4x over x. Now that these bottoms all match, they actually can just kind of go away. So x squared minus 21 equals 4x. I need everything on the same side, so minus 4x gives me x squared minus 4x minus 21. You always want to keep it in x squared x number format. Okay, equals 0. Equals 0 is kind of like our goal here. So again, I'm going to do my naked factoring since there's nothing in front of x squared. I can go off to the side and say, okay, what multiplies to negative 21 and adds to negative 4? Well, 21 is only 1 and 21, or 3 and 7. 7 needs to be negative. So I have x plus 3, since 3 is positive, times x minus 7 equals 0. Your solution is always opposite what you see. So here I see a plus 3, meaning x can be negative 3. Here I see a minus 7, meaning x could equal positive 7. So we would write our final answer. X is -3 and 7. Okay, 416. Let's see what that situation is. Okay, so 6 times x minus 5. I'm going to put that in parentheses so I remember that's already a group. Plus 6 over x squared minus 11x plus 30 equals 2 over x minus 6. Okay, so I see adding in here. I know I need common denominators. First thing I need to do is factor this guy so that I know what I'm working with. So 6 over x minus 5, we'll leave that for right now. Plus 6 over, again, naked factoring, so what multiplies to 30 adds to -11. -5, -6. So this is going to be x minus 5, x minus 6 equals 2 over x minus 6. Now we have to figure out who needs what. Okay, looking at this, these both have x minus 5, these both have x minus 6. Meaning this front group needs x minus 6. Whatever the bottom gets, the top gets. This guy has the two things he needs. This guy needs x minus 5. Okay, now that all the bottoms match, remember they can go away. So 6 times x minus 6 plus 6 equals 2 times x minus 5. To actually solve this, we are going to have to distribute. So 6x minus 36 plus 6 equals 2x minus 10. 6x minus 30 equals 2x minus 10. Let's see here. So subtract 2x, we have 4x minus 30 equals -10. Add 30, so 4x equals 20, and x equals 5. However, we have to look back at what it is the bottom is not allowed to be. Whatever we cross off, we have to consider. So x cannot equal regular 6 or regular 5. But we just got x equals 5. So if we got x equals 5, but x is not allowed to equal 5, that means we have no solution. Too bad, so sad. So always consider what x was not allowed to be. So like on number 15, when we crossed this off, this was saying x cannot equal 0, but we didn't get 0 here, so it wasn't an issue. Here, x cannot equal 6 or 5. Okay, well, we got 5, so that's a problem, so that's why we ended up at no solution. 417. Let's see. Okay, we want to solve for y. And we want to solve 1 over x equals 1 over y plus 1 over z. Solve for y really just means that y is our end goal. Okay, we want y by itself, not x like we usually do. Common denominator needs to have an x, a y, and a z because x, y, and z are the current denominators. So like before, figure out what they each need. So the 1 over x needs a y and a z on both the top and bottom because they have to match. The 1 over y needs an x and a z. Again, give it to the top as well. The 1 over z needs an x and a y, just to be consistent. Okay, cross those off. Just keep in mind, none of those can be 0. 1 times y times z is yz. 1 times x times z is xz plus 1 xy. So at this point, knowing we need y by itself, first thing we're going to want to do is subtract this xy over here. So yz minus xy equals xz. Okay, well, these both share a y, so I can undistribute it. Y times z minus x equals xz. Meaning at the very end of it, I can divide, so y equals xz divided by z minus x.